Imagine, like a 30,000-year-old survival mechanism, a genetic superpower that kept your ancient ancestors from bleeding to death in battle.
Right.
Now, imagine that exact same superpower is quietly waiting in your veins right now, ready to be triggered into a lethal threat by something as simple as, I don't know, a long flight or a daily birth control pill.
Yeah. It's a terrifying thought.
It really is. Today, we are taking you on a deep dive into the Nova Daily Genetics podcast series, specifically looking at Chapter 3 of Dr. Daniel Wallerstorfer's book, Unlock Your Genes for Precision Health. And our mission today is to explore this hidden biological blueprint inside you. We want to see how it interacts with everyday lifestyle choices to either, quietly protect you or put you at severe risk of blood clots.
Which is something a lot of people just don't think about until it's too late.
Right. So, okay, let's unpack this, because
Yeah.
to really understand the science here, we have to start with the human reality. The chapter opens with two stories, and they are incredibly sobering because they involve two young, vibrant people who did absolutely nothing wrong.
Literally nothing wrong. And they had zero warning. It really grounds everything we're going to talk about today in very stark, real terms. I mean, these aren't abstract statistics. These are sudden, catastrophic events.
Yeah, let's look at the first one. We have the story of Ashley Littlefield. She was just a typical 18-year-old. She had a boyfriend her family adored. She was studying for her final exams to become a beautician, and she was taking hormonal birth control.
Like millions of young women do every day.
Exactly. So she had just gotten back from a cruise with her family. Picture a sunny Saturday, right? She's hanging out in her boyfriend's backyard, and around 7 p.m., she drives over to her parents' house to help with the barbecue the next day.
Standard weekend.
Her father actually sees her pull up. He watches his eldest daughter get out of the car, walk up the 2 steps to the porch, reach for the door handle, and suddenly, she just collapses.
It happens in the blink of an eye. I mean, one moment, a perfectly healthy teenager is walking up the steps, and the next, her body is completely shutting down.
Yeah. Her father rushes over, but she's already lost consciousness. They call emergency services. In a brief moment of waking up, she whispers to her dad, "I had trouble breathing."
Oh, wow.
Her dad intuitively starts CPR right as the ambulance arrives, but despite everything, she didn't survive.
It's just devastating.
And then there's Richard Levins, completely different profile, but the exact same tragic result. Richard was this athletic, incredibly fit teenager on track to become a professional football player.
Super healthy kid.
Right, but he had been complaining about some pain in his left leg for about 2 weeks. A doctor looked at it, figured he was an athlete, and just dismissed it as a minor sports injury. Told him to wait and see.
Which, from a purely statistical standpoint at a standard clinic, that sounds like a reasonable assumption for a teenager playing heavy impact sports.
Right, you don't immediately jump to...
You don't jump to a life-threatening vascular event, no.
Yeah. But a few days later, Richard is on his way to soccer practice with his mom, and he just faints next to her. His last words were identical to Ashley's. "Mom, I can't breathe." By the time the ambulance got there, he was gone.
Yeah.
So break this down for us. What exactly happened inside the bodies of these two young people?
Well, what happened is a process called thrombosis. To visualize this, imagine your blood vessels as a massive, complex plumbing system.
Okay, pipes.
Got it. Normally, the blood flows smoothly. But in both Ashley and Richard, a blood clot, a solid mass of coagulated blood formed in a deep vein. Now, the immediate danger isn't necessarily where the clot forms.
It's where it goes.
Precisely. The danger is that it doesn't stay put. It broke loose from the vessel wall and began traveling through the bloodstream.
It becomes like a rogue blockage just moving through the pipes.
Exactly that. It washes through the wider veins, moving closer and closer to the heart until it gets pumped into the pulmonary artery.
Which goes to the lungs.
Right. And this is where the vessels start to branch out and get narrower and narrower. Eventually, that clot reaches a vessel it simply cannot pass through.
Yeah.
It wedges itself in tight and completely blocks the blood supply to the surrounding tissues.
And because both Ashley and Richard specifically said they couldn't breathe, that tells us exactly where this rogue clot ended up.
Yes. In both of their cases, the clot traveled into the lungs, causing what is medically known as a pulmonary embolism. This is the most life-threatening form of thrombosis.
But wait, if their airways weren't blocked, why couldn't they breathe?
So the reason they felt like they couldn't breathe isn't because they couldn't get air into their lungs, it's because the blood could no longer reach the tiny air sacs in the lungs to pick up oxygen.
Oh, wow. So the oxygen is there, but the blood can't get to it.
Exactly. The tissues are instantly starved. Within a very short time, That catastrophic drop in oxygen leads to unconsciousness and, in many cases, death.
It's terrifying because it is entirely invisible from the outside. But the chapter also notes that the destination of the clot dictates the crisis, right? If it goes somewhere else, the name of the emergency changes.
That's a crucial point, yeah. If we connect this to the bigger picture of cardiovascular events, it's the exact same underlying mechanism.
Just a different location.
Right. If that traveling blood clot bypasses the lungs, travels up to the brain, and lodges in a narrow cerebral vessel, it starves a portion of the brain of oxygen. We call that a stroke.
Okay.
If it happens in the coronary arteries feeding the heart muscle itself, it causes a heart attack.
Yeah.
But the pulmonary embolism is uniquely sudden in how it shuts down the body's entire oxygen supply chain.
I want to pause here and look at the odds because honestly, something isn't adding up for me.
Okay, let's hear it.
The text mentions that roughly 1 in 20 people develop a thrombosis over a 30-year period. But taking a cruise, playing sports, taking hormonal birth control, these are incredibly common activities.
Very common.
So if 1 in 20 people get this over 3 decades, why did it strike Ashley and Richard when they were just teenagers? Is risk just like stacking blocks? You know, you have 1 block for birth control, 1 block for a long trip, and if you stack enough bad habits, eventually the tower just tips over.
That's a very common way to think about it. But it's actually the wrong mathematical model for human biology. Risks in this context don't just add up like blocks, they multiply.
They multiply.
Yes. In medicine, we say they potentiate each other.
Walk me through what that actually looks like in practice.
Sure. Let's start with standard lifestyle factors. These increase your baseline risk, but usually only moderately. For example, the data shows that being a smoker increases your risk of developing thrombosis 1.43-fold compared to a non-smoker.
Okay, so a small bump.
Right. Obesity increases the risk by a factor of 2.75. And in women, taking hormonal contraception increases the risk by roughly a factor of 2.73.
Okay, so if you take the pill, your risk is nearly 3 times higher. That sounds significant, but I imagine doctors consider that a calculable, acceptable medical risk for most healthy people.
On its own, it absolutely is an acceptable risk. But here's where we have to look beneath the surface at the genetic blueprints. We all have genes called the prothrombin and factor V genes.
Factor V, like the Roman numeral 5.
Exactly, factor 5. Think of them as the body's natural built-in blood thinners. Their entire job is to keep the blood flowing smoothly and prevent it from clumping together.
So they are the traffic cops keeping the blood moving.
Good analogy. But what if those traffic cops are asleep on the job? If you have a defect in just one of those genes, your baseline risk of developing a clot over your lifetime isn't just slightly elevated, it is 5 to 7 times higher than someone without the defect.
Wow, 5 to 7 times?
Yeah, and in rarer cases, where a person inherits a defective copy from both parents, meaning both versions of the factor V gene are defective, the risk skyrockets up to 80 times higher.
Wait, 80 times? That is a staggering jump.
It is. But let's go back to the much more common single genetic defect, which carries a 7-fold risk. This is where your block stacking analogy falls apart and the multiplier effect takes over.
Okay, lay it on me.
Let's look at the specific clinical math from the book. If a woman has a 2.75-fold risk, because she uses a hormone contraceptive, and she also unknowingly has a 7-fold risk due to this genetic defect, her body doesn't just add those two together.
So it's not 2.75 plus 7.
No. The interaction multiplies the danger to a massive 26-fold increased risk.
Oh, wow. So a completely normal, everyday lifestyle choice like taking the pill becomes a massive life-threatening danger solely because of a hidden genetic multiplier.
According to the data, 1 in 12 women, that's 8.5% of all women, who use the pill or a hormone-releasing IUD and carry this genetic defect will develop a thrombosis.
1 in 12. That's so high.
It is. And this is exactly the trap Ashley fell into. She had the gene defect, which gave her that hidden 7-fold risk, and she added the contraceptive hormones on top of it, triggering the multiplier.
And Richard?
Richard had the genetic risk alone, and combined with whatever minor injury he sustained playing sports, that was enough to trigger the fatal pulmonary embolism. Neither of them had any idea they were walking around with this invisible threat.
The numbers in the chapter really put this into perspective. Statistically, about 1 in 50 people carry a thrombosis gene defect.
Right.
And to break that down further, 1 in 83 people of Caucasian descent has the factor V Leiden gene defect, and 1 in 140 has the prothrombin defect.
Yes, those are the specific numbers.
But that raises an obvious question for me, honestly. If this mutation is so incredibly deadly, why hasn't evolution weeded it out? I mean, why do 1 in 50 people still carry a gene that basically wants to clot their blood to death?
It seems counterintuitive, doesn't it? But we have to remember that evolution doesn't care about our modern lifestyles. It doesn't care about birth control pills or transatlantic flights.
It just wants you to survive to have kids.
Exactly. It only cares about survival in the environment where the mutation first appeared. To understand this, we have to rewind the clock about 30,000 years to northern Africa.
Okay, set the scene for us.
This specific mutation, the factor V Leiden mutation, originated in northern Africa and then spread with human migration into the Middle East and gradually up into Europe. Now think about the primary threats to human life 30,000 years ago. You were a hunter-gatherer.
So you're dealing with predators, tribal conflicts, hunting accidents.
Exactly. And if you suffered a severe injury or a battle wound back then, the biggest immediate threat wasn't an infection setting in a week later. The immediate threat was bleeding to death on the plains.
Right.
Scientists believe this genetic defect actually provided a massive benefit to the people who carried it because it made their blood coagulate or clot much faster than normal.
Oh, I see. So if they got slashed by a predator or punctured in a conflict, their hyperclotting blood meant the wound sealed up rapidly.
Exactly. Faster clotting meant less blood loss, which meant a significantly higher chance of surviving the trauma. If you survive, you reach reproductive age, and you pass that hyperclotting gene on to your children.
That makes total sense. In that brutal ancient environment, it was an incredible evolutionary advantage.
But flash forward to today, and the risk of dying from a spear wound or an animal attack is virtually negligible for most of us.
Which turns this ancient survival superpower into a modern liability.
Exactly. Today, it is estimated that about 40% of all cases of thrombosis are directly linked to this single genetic defect.
Yeah.
It's a classic evolutionary trade-off. What kept your ancestors alive is now putting you at risk.
The demographics on this are fascinating, too. The book points out that this defect is almost non-existent in Asia, but it affects about 5% of the population in Europe. But the real outlier mentioned in the text is Lebanon.
Yes, the statistics there are remarkable. The incidence of the factor V defect in Lebanon is 14%.
14%? That's more than 1 in 10 people.
It creates a unique public health challenge. It puts Lebanese women who use hormonal contraception at an exceptionally high risk of triggering that multiplier effect.
Wow.
It's a perfect storm of ancient genetics clashing with modern medicine. If we combine the factor V and prothrombin gene defects across the broader European population, about 7% carry at least one of them.
Meaning?
That means statistically, 1 in every 14 women of European descent who take hormone contraceptives has a drastically increased risk of a blood clot, entirely under the radar.
And this is exactly why we're doing this deep dive. Let's move from identifying the threat to practical application. Because when people hear blood clot, they almost always default to one very specific prevention method: aspirin.
Oh, right.
Everyone knows someone who takes a daily aspirin or pops one right before a long flight just to, thin their blood. Problem solved, right?
You would think so, given how common the advice is. But it is completely wrong when it comes to travel thrombosis.
Really, completely wrong.
Entirely. To understand why popping an aspirin on a plane won't save you, we have to look at the mechanics of your circulatory system. You have 2 main types of blood vessels, arteries and veins.
Right. Arteries take oxygen-rich blood away from the heart to the body, and veins bring the depleted blood back.
That's the basic loop. But the physics of those 2 vessels are very different. Arteries transport blood away from the heart under high pressure. Think of them as high-speed highways.
Okay.
Veins transport it back to the heart against gravity at a much lower pressure. Think of them as slow-moving back roads. Because the pressure and flow are entirely different, the way clots form in them is completely different.
So they aren't the same type of clot.
Not at all. If a clot forms in a vein, it's a venous thrombosis. In an artery, it's an arterial thrombosis.
So when you are cramped in economy class for an 8-hour flight to Europe, what kind of clot are you actually risking?
You are risking a venous thrombosis. What happens mechanically is that sitting for long periods with your knees bent dramatically slows down the blood flow in your leg veins. You aren't contracting your calf muscles to push the blood back up to your heart.
Right, you're just sitting there.
Exactly. So the blood essentially pools and solidifies in these low-pressure dead zones. This is commonly known as economy class syndrome.
And where does aspirin fit into this plumbing problem?
It doesn't. Aspirin, which relies on the active ingredient acetylsalicylic acid, developed by Bayer over 120 years ago, is an incredible drug. But clinical research proves that it only prevents arterial thrombosis.
Wait, it only works on the high-speed highways?
Only the highways. It prevents clots in the high-pressure arterial system, which is why it is so effective for seniors trying to prevent heart attacks or strokes.
Oh, I see.
But taking an aspirin before a flight to prevent venous pooling in your legs, you are trying to clear a traffic jam on a slow back road by changing the speed limit on the highway. It is completely unsuitable for travel thrombosis.
That is a massive misconception. So if you're taking an aspirin before you get on your next transatlantic flight thinking you're safe, you are entirely unprotected.
Completely
But
unprotected.
the chapter throws in a genetic twist even for the arterial side of things, doesn't it? Even if you're taking aspirin for the right reason, like a senior trying to prevent a heart attack, it might still fail.
This is where precision medicine becomes vital. We know from genetic studies that a significant portion of the population is what we call aspirin resistant.
Aspirin resistant.
Yeah. There is a specific gene called ITGB3. A variant of this gene affects about 13% of Europeans. For those individuals, acetylsalicylic acid provides absolutely zero blood thinning effect.
Literally zero protection.
None at all. Now, to be clear, aspirin does work beautifully for 6 out of 7 Europeans. But for that 13% who might be dutifully taking it every morning to reduce their risk of an arterial clot, the drug isn't doing a thing.
They are walking around thinking they have a safety net when they don't.
Exactly. They require a completely different class of medication to get the same protective effect.
If synthetic hormones in a tiny daily birth control pill can trigger a 26-fold risk explosion, what happens when the body naturally floods itself with hormones? I'm talking about pregnancy.
It's a critical vulnerability. The medical reality is that a blood clot during pregnancy is the leading cause of death in expectant or new mothers worldwide.
The leading cause of death, that really puts it into perspective.
And the danger doesn't magically disappear the moment the baby is born. The first 6 weeks postpartum are particularly dangerous.
Really? Why then?
Well, during that window, there is a 20-fold increased risk of thrombosis. It's a compound physiological effect. You have the physical tissue injuries sustained during childbirth, combined with incredibly high fluctuating levels of hormones flooding the mother's system.
And I imagine the genetic multipliers we discussed earlier, those ancient survival genes, they come roaring back into play here.
They absolutely do. Research shows that half of all women who suffer a thrombosis during pregnancy have a genetic defect in one of 3 specific genes: the factor V gene, the prothrombin gene, or a third one we haven't mentioned yet called the MTHFR gene.
MTHFR, what does that gene do? How does it cause a clot?
So people with a mutation in the MTHFR gene generally suffer from elevated levels of an amino acid called homocysteine. Too much homocysteine in the blood damages the inner lining of your blood vessels.
In what way?
Think of a healthy vein like a non-stick pan. The blood glides right over it. But homocysteine acts like microscopic sandpaper, creating rough patches on the vessel walls.
Oh, that sounds bad.
It is. When platelets hit those rough patches, they catch, snag, and begin to clump together. In pregnant women, this vessel damage doesn't just lead to pregnancy thrombosis. It can trigger severe complications, including miscarriage.
Wow.
To put the genetic risk in perspective, a woman with a factor V defect has a 15 times greater risk of suffering a thrombosis during and immediately after pregnancy than a woman without it.
But we aren't just here to scare people. What is the solution? If a woman knows she wants to have children and she discovers she has one of these mutations, what can she practically do?
The clinical solution is highly effective. Women with these specific genetic profiles can begin therapy with low molecular weight heparin.
Heparin.
Yes, heparin actively inhibits blood clotting, significantly neutralizing that multiplied risk.
But is it safe for the developing baby? You always hear about the dangers of medications crossing into the womb.
It is remarkably safe. The affected person injects the heparin herself, and it is completely harmless to the fetus because of its physical size.
The size of the needle.
No, the size of the molecule. The heparin molecule is simply too large to cross the placental barrier and enter the fetus's bloodstream. It stays in the mother's system, doing exactly what it needs to do.
Oh, that's brilliant.
But the recurring tragedy here is that those 1 in 50 affected women are usually entirely unaware they carry the defective gene until it's too late. This is why the book strongly emphasizes that, especially after experiencing a miscarriage. Carrying out a genetic analysis is essential. It allows doctors to start that stabilizing heparin therapy for future pregnancies.
Okay, so heparin is the clinical intervention for pregnancy, but what about the rest of us? What actionable advice does the chapter give for optimizing our daily environment to keep our blood from clumping?
The book outlines several very precise, non-medical steps you can take today. First and foremost, hydration. You need to drink at least 1.5 liters. That's roughly 3 pints of water per day. Unsweetened herbal teas or lemon water are great too.
That just flushing the system.
Exactly. This physically ensures your blood remains diluted and maintains its liquid viscosity.
Let me guess, my morning coffee doesn't count towards those 3 pints.
Unfortunately, no. Alcohol, coffee, and black tea all have a dehydrating effect on the body, making them counterproductive to keeping your blood thin.
Got it. What else is on the prevention list?
Maintaining a normal body weight is crucial, as being overweight increases the risk of thrombosis almost 3 times. Quitting smoking is another major one.
Does that make a big difference?
A huge difference. Eliminating nicotine reduces your risk fourfold. Nicotine physically constricts the vessel walls. It acts almost like a chemical tourniquet from the inside, giving the blood less room to flow, which forces it to jam up.
Makes sense.
Finally, stretch your legs regularly. If you are on a long flight, stand up, walk the aisle, contract your calf muscles to literally push the blood out of those dead zones. And if you know you are genetically predisposed, consult your doctor before long flights. They might prescribe medical compression stockings or a preventative injection of heparin.
You know, reading through the sources for this deep dive, I was really struck by the National Blood Clot Alliance. They launched a major information campaign called Stop the Clot. Their website is stoptheclot.org.
Yes, it was launched over 15 years ago by people who were personally affected by these exact gene defects.
And the most sobering statistic from their site was that out of more than 200 patient case histories shared there, at least 70 of them reported that a defect in one of these relevant genes was finally discovered to be the triggering factor.
Yeah.
But usually only after years of painful misdiagnosis.
Which brings us to the ultimate line of defense: early detection. You need to know what a clot looks and feels like before it becomes a pulmonary embolism.
Instead of just reading a medical list, let's map this out for the listener. Imagine the warning lights going off in different sectors of your body. Let's start with the origin point, usually the legs. What are the alarms?
For a venous thrombosis in the leg, you are looking for swelling in the affected area, localized pain or sensitivity, increased heat in the skin when you touch it, or visible redness and discoloration.
Okay, and if those alarms are missed, and the clot breaks loose and travels to the lungs like it did for Richard and Ashley.
The lung alarms are difficulty breathing, chest pain that gets noticeably worse when you take a deep breath or lie down, unexplained coughing, sometimes coughing up blood, and a racing erratic heartbeat. If you experience those, seek medical attention immediately. Call 911 if you are in doubt.
Finally, what if the clot bypasses the lungs and hits the brain, triggering a stroke?
The brain alarms are sudden numbness or muscle weakness in the face, arms, or legs, especially on one side of your body. You can self-test this quickly. Does one side of your face droop when you try to smile? Can you lift both arms equally well?
Okay, so asymmetry.
Right.
Okay.
Also watch for sudden confusion, trouble understanding people speaking to you, or problems forming words yourself. Sudden vision problems, loss of balance, unexplained dizziness, or a severe sudden headache are also major red flags. Again, call 911 immediately.
This all loops back to the core message of Dr. Wallerstorfer's chapter. Nothing beats information. Knowledge is power, especially when it comes to the invisible code written into our cells.
Absolutely.
The author highly recommends genetic analysis for these thrombosis genes, particularly if you have European ancestry, where these multipliers are most heavily concentrated. To put it in perspective, the book notes there is a 20% chance that a woman in your own circle of acquaintances will develop a thrombosis due to a combination of a gene defect and hormone use.
It's staggering.
Finding out your genetic blueprint before a crisis hits can quite literally be the difference between life and death.
It's about moving from being reactive to being proactive. Knowing your genes allows you to make informed, personalized choices. To know for sure if that birth control pill is a safe option for your specific biology, or if that long international flight requires extra medical precautions.
Exactly. So, we'll leave you with this final mind-bending thought to mull over. If a 30,000-year-old genetic battle, a hyper-clotting mutation designed to stop a hunter-gatherer from bleeding out on the ancient plains of northern Africa, might be quietly circulating in your veins right now. Wait, sorry, no. Might be quietly circulating in your veins right now. What other ancient survival tools are hiding in your DNA, just waiting to be understood?
It really forces you to look at your own body and your ancestry in a completely different light.
It really does. Thanks for joining us on this deep dive. See you next time.